Imagine a world where the scars of ancient cosmic collisions are still visible deep within its core. NASA's InSight mission has unveiled a surprising aspect of Mars. Its mantle is dotted with massive chunks of material, remnants from colossal impacts that occurred 4.5 billion years ago. These discoveries, made possible by the now-retired InSight lander, offer a unique window into Mars' internal structure and its tumultuous past. The InSight lander, which concluded its mission in 2022, detected these fragments deep within the Martian mantle. These chunks, some as large as 2.5 miles, 4 kilometers across, are believed to be the remnants of massive asteroids or protoplanets that collided with Mars during the early days of the solar system. The impacts were so powerful that they melted vast swaths of the planet's crust and mantle, creating enormous magma oceans and embedding these fragments deep within the mantle. But here's where it gets controversial. The early solar system was a chaotic place, filled with various rocky objects, some as large as protoplanets. The exact nature of what struck Mars remains a mystery, but the evidence of these impacts is clear. Unlike Earth, which has been reshaped by tectonic activity, Mars has remained relatively unchanged, preserving these ancient fragments in its mantle. The findings, published in the journal Science on August 28, 2023, provide unprecedented insights into the interior of Mars. Lead author Konstantinos Charalambous from Imperial College London explained, "We've never seen the inside of a planet in such fine detail and clarity before. What we're seeing is a mantle studded with ancient fragments. Their survival to this day tells us Mars' mantle has evolved sluggishly over billions of years. On Earth, features like these may well have been largely erased." InSight, managed by NASA's Jet Propulsion Laboratory, placed a highly sensitive seismometer on Mars in 2018. Over the course of its mission, the seismometer recorded 1,319 Marsquakes, providing valuable data on the planet's interior. Seismic waves, which change as they pass through different materials, allowed scientists to map the size, depth, and composition of Mars' crust, mantle, and core. Tom Pike, a co-author from Imperial College London, added, "We knew Mars was a time capsule bearing records of its early formation, but we didn't anticipate just how clearly we'd be able to see with InSight. Mars lacks the tectonic plates that cause earthquakes on Earth, but it does experience quakes from rocks cracking under heat and pressure, and from meteoroid impacts. These impacts generate high-frequency seismic waves that travel deep into the mantle, altering their characteristics as they pass through different materials." The new study identified 8 Marsquakes whose seismic waves contained strong, high-frequency energy that was distinctly altered as they traveled through the mantle. Initially, researchers thought the changes were occurring in the Martian crust, but further analysis revealed that the alterations were happening deeper in the mantle. Using computer simulations, the team determined that the changes were due to small, localized regions within the mantle with a different composition from the surrounding material. These lumps, Charalambous explains, are like shattered glass, large shards with many smaller fragments. This pattern is consistent with a large release of energy that scattered material throughout the mantle, aligning with the theory that asteroids and other planetary bodies frequently bombarded the young planets in the early solar system. On Earth, the crust and upper mantle are constantly recycled by plate tectonics, which pushes material into the planet's interior where it is mixed through convection. Mars, however, lacks tectonic plates, and its interior circulates much more slowly. As a result, the fine structures observed in the mantle have remained intact, providing a unique glimpse into the planet's history. This discovery not only sheds light on Mars, but also hints at what might be found beneath the surfaces of other rocky planets without plate tectonics, such as Venus and Mercury. The InSight mission, part of NASA's Discovery program, was a collaborative effort involving multiple international partners, including France's CNES and Germany's DLR, who provided critical instruments for the mission. What do you think? Could similar structures exist on other planets, and what might they reveal about the early solar system? Share your thoughts in the comments below.